Yeah, so my name's Oliver Rue. I'm a software engineer at Bloomberg in New York City, and I'm here today to talk to you about a tool that my team built and some of the design that went into it. At Bloomberg, I'm on a team that builds automation and tooling to make our data centers more reliable, scalable, and efficient. Without getting into too many details, a while back we were tasked with building a new tool. Its purpose was to unify the existing tools used by our operations teams, and in doing so, increase their repeatability and efficiency. Now, we knew we wanted one API to host the tool set, but we also needed a CLI for individuals to interact with it. To achieve this, there's a fairly common pattern that you might be familiar with. On the left here, you have a REST API with various methods and paths. It speaks JSON, and it's designed to be interacted with programmatically. And on the right, you have a CLI, made for human interaction, that translates between the REST API operations and more human-friendly commands, syntax, and output. Usually these applications are tightly coupled, and the CLI is purpose-written specifically for the latest API spec. However, from past experiences, we knew this design presented a couple challenges. First, we knew our API would have quite a few operations, and depending on the requirements of our infrastructure, might indeed never stop growing. While building a tightly coupled API and CLI might be easier at first, keeping the two in sync can be cumbersome as the project grows. So let's talk a little bit about why. A tightly coupled API and CLI is a simple and straightforward approach. The API is for programmatic access, the CLI is for human interaction, and the CLI code translates between the two. But when an API and CLI are tightly coupled, every time you modify one, you likely need to modify the other. And you need to continually maintain two separate code bases with different automation, deployments, and team knowledge. Plus, the deployed API and CLI versions can get out of sync and often require synchronized deployments to avoid compatibility issues. So it was at this point that we had an idea. We were already planning on maintaining good API docs for other API clients. So what if the CLI commands were just based on the API documentation? With this model, the CLI would generate its commands by simply reading the docs every time it starts. So with this design, when your CLI is auto-generated, new features and fixes only require an API change. And because of this, the API and CLI can never get out of sync. One drawback is that it's quite a bit more complex than the other model. And it should be noted that even with this design, you still have two separate code bases, and you need to deploy the API and CLI separately. But the advantage comes from how this scales over time. In the beginning, the CLI and API will likely both be getting changed very frequently because they're under active development. But when the CLI matures, the API can still get continual updates such as bug fixes, new features, etc. But the CLI should hopefully only require minimal maintenance. Effectively, at a certain point, you can stop deploying the CLI, but continue changing the API, and the CLI gets updated for free. So we put together a first draft with simple one-to-one mappings between the API and CLI. API paths would map to space-separated CLI commands. Each path parameter, query parameter, and request body field would map to a single CLI flag, and the CLI would just print the JSON API response. We weren't actually the first people to think of something like this. It's been done a couple times in the past, and your favorite LLM can probably do it for you as well. But let's look at the scheme in a little more detail. Here's a sample API endpoint that's used to list all the servers that an API knows about. It uses a get method. Its path is /device/compute/servers. It takes an optional cluster_name query parameter to filter results by cluster, and it responds with a JSON blob containing a list of found servers. Now, if we were to naively generate a CLI command from this endpoint, it would look something like this. To use it, you need to fully type out infra_CLI get device compute servers, specify the cluster with the --cluster_name flag, and you get back an HTTP status code and a huge JSON blob. If you can't already tell, this scheme leads to a bad CLI and is not much better than just using curl. So we realized that simply bolting the API and CLI together with some simple mappings was not going to work. Doing that created a really poor user experience on the CLI. The problem is that good APIs and CLIs are designed for very different purposes. APIs are made for programmers writing computer code, but CLIs are fundamentally a human interface. The underlying issue was that we were trying to map API concepts to the CLI domain. But REST API paths were never meant to be typed CLI commands. API parameter names were never meant to be typed CLI flags. And API response data is usually not meant to be consumed raw by humans. As we developed our first draft and ran into these issues, we kept trying to think up different ways to modify our API so that its directly mapped CLI commands would be more human-friendly. Perhaps we should just shorten our API paths so the CLI commands are easier to type. Or maybe API path parameters could always become positional arguments in the CLI and not require flags. We had a couple more ideas like this, but ultimately we were looking at it in the wrong way. The end result would have been a bad API, a bad CLI, or both. If our CLI was going to auto-generate its commands from the API, we needed a translation layer to bridge the two. Then it occurred to us, maybe we can include this translation layer in our OpenAPI docs. The docs already contain all the basic information a client needs to know to use the API, so why not include a little additional information on how to define the CLI interface to the API as well? So, one problem we saw before is that typing out a long API path as a CLI command is a lot of work for a human and a very poor CLI user experience. Ideally, long API paths could be abstracted into succinct, intuitive CLI commands. So why not have the docs just define a CLI command for a given API endpoint? Then you go from this to this. Shorter commands mean less typing, but they're also cleaner and easier to understand. Another obvious problem we saw was API output formatting. REST APIs often and should speak JSON, but JSON is not very human-friendly. You can see that here. Even if we pretty printed this JSON, it's still not going to be easy for a human to read. But what if the docs included instructions on how to translate the JSON into something easier to read? Then you can go from this to this. And to accomplish this translation, but to keep the CLI completely decoupled from the API, we use Jinja templates. If you're not familiar with Jinja, it's a relatively simple templating language with widespread use across the Python community. So the docs contain a server-defined Jinja template for each API endpoint, and the CLI simply has to pass the API response through the template to get the human-friendly output. Sorry, one sec. There's a bit more nuance to the output formatting problem. We also observed that CLI users often wanted the ability to display the same essential data, but in slightly different ways. For example, what if the user here wanted the output as CSV instead of the table shown? It would be kind of silly to have multiple virtually identical API endpoints whose only difference was how the data was displayed to the CLI user. But we could have multiple Jinja templates for a single API endpoint and just give the user a way to choose between them. We could have one template to display the output as CSV, triggered by the --CSV flag. Maybe another template to display just network information, triggered by the --net flag. And of course, all these options would be shown to the users in the command help text. You also might notice the --JSON flag there as well. We included that in all of our commands to give the user the option to get the raw JSON API response so they could pipe it to a file or JQ or something else. Another issue we noticed involved how arguments were passed to the API. Originally, we planned on adding one CLI flag per API argument. But look at this getServer command, which is generated by the API endpoint code shown to the right. That --hostname flag isn't really buying us much, because it takes just a single required argument, and it's just more for the user to type. So why not include the ability to make arguments positional, like this? A simple change, but it definitely makes the command a lot more human-friendly. Staying on the topic of arguments, we noticed another unfortunate consequence of mapping API arguments directly to the CLI. It's often handy and good code hygiene to have descriptive variable names in your code. Here on the right, we have an example API endpoint that collects logs for a given server and saves them to a location on a file system. To represent the log file's destination, we have a descriptive variable named destination_filepath. While this variable name might be helpful to programmers, it's an awfully long and cumbersome CLI flag to type, not to mention that the use of underscores in flags doesn't really follow POSIX conventions. So I want to have the ability to specifically define the CLI flag and short flag used to represent a given API parameter, like this. To specify the destination file path, now you can just use --dest path or -p. Again, it's little improvements like this that go a long way in improving a CLI user's experience. The final problem we observed with API and CLI argument mapping was that sometimes arguments just couldn't be easily represented using simple strings. For example, what if the CLI command needed to upload a local file? What about Boolean CLI flags whose simple presence represents true? What about list arguments with a fixed or dynamic number of entries? We knew we needed to build a dynamic system to represent unusual API arguments on the CLI in a human-friendly way. So now that we have a clear understanding of the problem, let's talk about how to implement it. While we used many of the great open source projects I show here, we're going to primarily focus on FastAPI and Pydantic. If you aren't familiar with FastAPI, it's a great open source web framework for Python. While there are numerous good reasons to use FastAPI, one feature we love is the built-in support for OpenAPI documentation generation. Here on the left, we have a simple FastAPI implementation with 2 endpoints. With just this code, FastAPI automatically generates the OpenAPI docs you see on the right. However, what you see on the right is not really the documentation itself, but just a pretty rendering of the actual documentation, which is defined in JSON and looks something like this. This JSON is the actual OpenAPI spec, which contains all the information a client needs to know to call the API. And as you can see, the JSON contains a section for each path in the API. This is what the CLI will be parsing to generate its commands. Let's take a closer look at how the OpenAPI JSON defines an API endpoint. Here on the right, you can see the OpenAPI JSON generated for the getHello endpoint on the left. It contains a summary, a description of parameters, along with a little bit more information that I left out for simplicity. For our use case, we need to define extra information for each API endpoint so the CLI can configure itself. So we just added an extra section like this. Each endpoint gets a CLI section that can define things like the actual CLI command, the Jinja formatters, and more. Fortunately for us, FastAPI has a neat keyword argument called OpenAPI Extra that allows the user to embed arbitrary information into the OpenAPI spec for an individual endpoint, and it's used like this. You just include your arbitrary object in the endpoint decorator, and it's automatically nested in the generated OpenAPI spec. We could just shoehorn a huge dictionary into every endpoint decorator to define the entire CLI spec, but that would be awfully crude and not very readable. So instead, we decided to implement our own child class of the FastAPI API router, but added some additional arguments to include the CLI specification with an API endpoint, something like what's shown here. With that, we can now define our API endpoints and associated CLI commands like this. We write our endpoints just like we normally would in FastAPI, but with the option of specifying a CLI command in just a few extra lines. Of course, you still need to define the specific Jinja templates to print the CLI output, but in many cases, we found that different endpoints could use identical templates, and there were tons of opportunities for code reuse. While this is all you need to describe the CLI command for an endpoint, we still haven't covered how we'll handle CLI arguments. FastAPI already offers a rich set of tools to define API argument behavior. Here we use the query class to define an API endpoint query parameter, and the field class to define individual fields and a JSON request body with Pydantic. There are similar classes to define other types of API arguments as well. The information defined in these classes is also reflected in the generated OpenAPI JSON. And just like the FastAPI endpoint decorators, it's easy to tack on extra information. So just like the endpoint CLI specification, we use Pydantic to define our model, add it to the argument declaration, and it shows up in the OpenAPI JSON where it can be consumed by the CLI. All right, so now that we have all the pieces to implement a CLI command for an API endpoint, let's put everything together. Here on the left, we have our endpoint from earlier that's used to get a list of servers. And on the right, we have a CLI command that we want to be generated for this endpoint. To implement the CLI command, all you have to add is this. Just include a small amount of information about the CLI command, and FastAPI, OpenAPI, and our dynamic CLI take care of the rest. All right. By now, I hope you have a pretty good understanding of the design and implementation, but I think a live demo is a good way to showcase the utility of what we built. So I'm going to run through this quickly, but it's not important that you read every line I show here. Give me just a second to rearrange my monitor. Okay, so in this window, I'm going to run something called Infra API. It's a mock API I wrote to interact with infrastructure. All you really need to know about it is that it's written in FastAPI, and it includes some of the annotations I just described to define a CLI for this API. It's running here locally on my computer on port 8001. And in this window, I'm going to run something called Infra CLI. Infra CLI is a toy CLI to interact with infrastructure, but what it really is just a thin wrapper on top of Infra API. So here we have a bunch of subcommands: get server, delete server, new server, and list servers. These are all commands based on endpoints that are in Infra API. So let's check out the list servers command. If we run that, that's pretty big. If we run list servers, we get this nice column-separated table of all the servers the system knows about. If we run --help, we can get some information about the command. So it's used to display a list of known servers in the system. It's got a --cluster flag to filter results by cluster. And it's got a couple formatters down here to show the JSON output, show the output as CSV, and just show network information. Great. So we get some feedback from our users. First of all, they say, list servers is just too much for us to type. We want to type ls servers instead. Okay? They say you've got some pretty glaring typos in your help text, and you should probably fix those. All right? And finally, they say, this --CSV formatter is really helpful, but what would be really nice is the --TSV, or tab separated values formatter. Okay. Let's see what it takes to change those three pieces of behavior. So I'm going to pop over here real quick. I'm going to open up the source code for this. It's hard to follow live coding, and it's not important that you read everything here. I really just want to show you how little we have to change to make those changes. So here in infra-api.py, on line 72 and 86 is where we define the API endpoint. If you're familiar with FastAPI, this should look familiar to you. So on line 76, that's where we define the endpoint CLI spec, where we define the CLI command that we want for this API endpoint. So here's the help text on line 77. I'm going to fix that real quick. Line 78, we've got the command. It used to be list servers, but let's change it to ls servers. And lastly, they want to add a TSV formatter. So the formatters are defined in another file called format.py. And TSV is a lot like CSV, so let's just copy that real quick. I'm just going to rename it. I'm going to modify this really quickly to be tabs instead of commas. Let's change our flag to --tsv. Maybe we add a short flag of just -t. And then finally, we want to change our description to display servers in TSV format. Last thing we got to do is add that to our endpoint. And finally, import it. Great. Just a couple small changes. So let's run it again. Start it up, so that's good. And let's go back to infra CLI. Now if we look at infra CLI, we see that list servers is now LS servers. And if we run LS servers, we'll see that the help text is fixed. And now we have an additional formatter flag for showing TSV. And we can try it out. Same information, but in TSV format, and we just defined this. So to recap what we just did, we just changed 3 specific pieces of CLI behavior by only changing API code. The CLI code didn't change 1 bit. All right, I want to show you one more thing. In this window, I'm going to run something called meal API. You don't need to know much about it besides it's written in FastAPI, and it's got the same annotations to define a CLI for it. And let's look at meal CLI. Cool. It's got a couple commands, and let's run a meal CLI meals. Prints out some meals for you. Cool. Just another CLI. What I really want to show you is that meal CLI and infra CLI are the same thing. They're both a program called auto CLI that we point at a server instance. So if you want to run infra CLI, you really just have to run auto CLI and point it at the infra CLI instance locally. If you want to run meal CLI, you just point it at meal API. That's one physical CLI code base for an infinite number of virtual CLIs, depending on what API you pointed at. And when you want to change your CLI behavior, you change your API code, and your CLI gets updated for free. That's all I got.
Thanks, Oliver. Please remember to ask your questions via Slido. It's the room lasagna. We have one question currently, when my phone unlocks. All right. How do you deal with more complicated use cases for CLIs that don't map one-to-one with the REST API? For example, if you have some desired CLI operations that might make multiple REST calls to multiple CLI APIs.
So that's something we've discussed doing in the past. And we've thought about having maybe some sort of like Jinja-defined language to kind of create a virtual CLI command where you could define on the server a CLI command which hits this API endpoint, filters the results, and feeds it to this API endpoint to kind of compose a bunch of API endpoints into a single CLI flag. We actually haven't gotten there yet because we haven't found many use cases for it, but it's something we've considered.
All right, the next question is, why didn't you separate the actions like get, delete, list, new from the resources like server, cluster, node? This violates CQRS.
Because I don't know the REST spec very well, and whoever you are, come tell me what I did wrong, and I'll fix it. Yeah.
Right. So right now there's no. Oh no, there's no. Someone new popping in. 1 second. What about the async API? For example, OpenAPI for event-driven architecture. Are you supporting that as well?
By async, I'm assuming you mean like kick off an operation and get back some reference to it, then follow it over time. I don't know if the person's in the room.
Usually, like with async API spec, you spec basically the events that are happening in your kind of infrastructure. And it's just a spec like OpenAPI for those. Is that your question?
I'm not sure we use that exactly. We do have some support for what we call async operations, so something that'll take a really long time. Re-image this server or something like that. And so you can kick it off. It kicks off a job in the background using some orchestration platform like Airflow or something else. And we've built some kind of basic bindings into our API that go back to the CLI that allows a user to track a job as if it were a single command, but really it's running asynchronously in the background.
All right. Are there any more questions in the room? Oh, no, no one popped in. How do errors get rendered with your CLI? Do you have any user-friendly ways of doing that?
Yeah, so the program I showed here is actually something I purpose wrote for the talk. Our internal one is still closed source at the moment, but we do have ways of detecting a specific error code and then also feeding that through a formatter as well. So if you know an error will look, if you want an error to look a certain way to the CLI user, you can detect its HTTP status code and like feed data through another error Jinja template to format a specific error for a user.
Maybe a good follow-up question to this. Are you planning to open source the code of your internal library?
Yes, I am. So we can't open source what it is right now because it's kind of tightly coupled with something that will always be closed source. But I've gotten permission from my management to kind of rip the two apart and then open source auto CLI. And so that's my plan in the coming months.
All right. Do you cache the response for help messages? So whenever you do the request to its different API?
Do I cache the response for help? No.
Okay.
We've thought about doing caching, and if it ever became an issue, we've considered like, yeah, we could just store the OpenAPI spec locally. But then that sort of might go against the idea of the CLI being this thin client that always generates itself in the API, because then the CLI could get out of sync with the API. So we would need another mechanism to cache the docs, but also communicate with the API to make sure that the docs that I cached are the latest ones, and if they're not, update them. We haven't done it yet because it's so fast you don't really notice it, but maybe in the future.
Another question is who the end users are of the CLI at Bloomberg. So do you think there are situations where having a UI instead of a command line tool would be more user-friendly?
Yeah, absolutely. And it's something we've considered. When we first designed this, it was, without getting into too many details, it was very specifically to replace certain CLI command line tools that people were using. But we already have like runbook platforms that are more like UI based, and we've been talking about a way to do something similar to what we did here, but on a UI to achieve the same goal.
Cool. And there's another question. Have you ever considered using Typer as a CLI tool? So basically, you know Typer?
Yes, I know Typer. So I've been looking, in open sourcing this, I've been looking how to kind of rip the auto CLI part out of our internal code base. And part of that might be using a new CLI library. We currently use argparse. I think Typer is great. There's nothing wrong with it, but at least when I looked at it originally, it's sort of like higher level. Like it makes it really easy to add some CLI commands to your code base. But we sort of need to like generate a CLI from specification as opposed to like decorating an endpoint or something like that. So at least when I looked into it, it seemed like Typer might not do exactly what we wanted. Click, which I think Typer uses under the hood, looked like it might be possible to do what we want to do. But to be honest, I haven't done a lot of research. So if I just said something incorrectly about Click or Typer, please come let me know.
All right, the last question is, why don't you use Swagger directly instead of like building an entire CLI around it?
Because Swagger isn't really user-friendly. Like if you wanted to do a post command on Swagger, you have to like go in and sometimes it's easy to type in your, type in like your query parameters and all that, but it's not very user-friendly, at least we found. And authentication is, it works through Swagger, but it doesn't support all like the unique authentication use cases that we have. So, yeah.
Thank you. Are there any more questions in the room? I'm happy to take them. Yes.
Yeah, that's kind of a follow-up question. I know, and you probably also know the requests module from Python.
Mm-hmm.
So, as I remember requests, it's very, very easy to make these calls, get, post, put, etc. Why don't you use this?
We do. In a Internally, we do a little bit. Maybe I don't understand the question. Use it instead of the CLI command? Yes. We have API clients that use requests or something else, but this was more like if someone is working on a server in a data center and wants to do a very specific operation to it, they've got their terminal in front of them, and they don't want to write out a script, requests, and then point it at our API endpoint, figure out how to get our auth token, give it the right arguments. Yeah, we would rather just have them use our kind of like pre-packaged command. I think what you're describing works, but that's sort of what we were trying to get away from, because we don't want individuals like Johnny over there has got his special way of rebooting a server, but Dave has another one, something like that. Like, we all want everyone to use the same command.
All right, that's it. Time is up. Thanks again to Oliver.